Hello there, Mr. Sutton here, bringing you the IM311 Extra Practice Solutions on solving systems of equations by graphing. On this problem, we're trying to find the solution to this system of equations. We're going to solve this by graphing these lines and then seeing where they intersect. So for the first one, I noticed that this is in mx plus b form, so I can just use the y-intercept and the slope to graph it out. It looks like I have a y-intercept of 4, so I'm going to begin at 4 on the y-axis. And then I'm going to use my slope, which is an invisible 1 over 1 next to the x here. So I'm going to start at this y-intercept, and I'm going to go up 1, right 1 for that slope of 1. And you can do the other direction too, down 1 and left 1 if you want. So drawing a line that goes through those points, there's my first line. Now I'm going to graph this other one and see where it crosses the first line. So for this other one, I have a y-intercept of 2, so that's 2 on the y-axis, and this is a slope of negative 1, so that's down 1, right 1, because this is really negative 1 over 1. So starting here at the y-intercept, down 1, right 1, and draw a line through those. And if I do this accurately, it looks like these are crossing at this spot right here, which is the point negative 1, comma 3. To solve this system of equations graphically, let me first graph each of these lines individually and then see where they intersect. So for the first one, we have a y-intercept of negative 1. So I'll put a negative 1 on the y-axis down here. And my slope is 5 over 4. So starting at my y-intercept, I'm going to go up 1, 2, 3, 4, 5, and over to the right, 1, 2, 3, 4. There we go. Draw a line through those as accurately as you can. I would use a straight edge if you could. And now we're going to graph this next line. This has a y-intercept of 3. So there's 3 on the y-axis. This one has a slope of 1/4, so that's up 1, right 4, which actually takes us to that second point we had for the first line. So we can just draw a line through those 2 points now. And it looks like they cross at this spot right here, which is 4, 4. On this problem, I'm trying to find the solution to this system of equations. Now what I have here are 2 lines, and I just have to figure out where they intersect. So since these only have an x or a y in them, I'm going to use my little Hoy-Vux trick of figuring out what I'm graphing. This first one, x equals negative 2, that's the Vux part of this. I only have an x, so that tips me off that I have a vertical line. So this is a vertical line where all the x values are negative 2 and the y values are, well, just all the y values. So I'll draw a vertical line through negative 2 right here. So there's that first one. And now y equals 1. Well, that's Hoy because it has the y in it. So that's a horizontal line where all the y values are 1. So that's this line right here. And it looks like these are crossing at negative 2, comma 1, which matches the x and the y value up there anyway. So that's the solution to this one. To solve this system of equations by graphing, I first need to put these in a form that's easier to graph, such as slope-intercept form. So let me start by getting y all by itself on these. So for this first one, I'll subtract 24x from both sides. So I have 18y equals 24x plus 36. Actually negative 24x because I subtracted it. And then I'm going to divide both sides by 18, so that'll give me y on the left. And over here I've got negative 24 over 18. Now I can reduce that by 6, so that's really negative 4/3 x. And then 36 divided by 18, that's going to be a plus 2. So this will be a little bit easier to graph. Before I graph that though, let me go on to this next one and just rearrange this. So let me do the same thing over here. I'll subtract 8x from both sides. So that's negative 8x minus 6 on the right side now. And dividing by 6 to get y by itself, I've got just y equals negative 8 over 6 is really negative 4/3 x. And then we have a minus 1. So graphing each of these, for the first one, I have a y-intercept of positive 2. So that's 2 on the y-axis right here. And my slope next to the x here, this is negative 4 over 3. So I can think of that as going down 4 and right 3. And let's just draw a line through those. For this next one, I have a y-intercept of negative 1. So that's negative 1 on the y-axis. And I have a slope of negative 4/3 for that one. So I'm again going down 4 over 3 and drawing that line. Now, if you were to extend these lines infinitely in both directions, you would see that they never cross. Because these are parallel lines, they have the same slope. So for this reason, since the lines don't intersect, there is no solution to this system of equations. On this problem, I want the solution to this system of equations. I'm going to do this by graphing, so I'm going to start by putting it in y equals mx plus b form for each equation. For the first one, I'll start by subtracting 4x, basically just trying to get y all by itself. So we've got 10y equals negative 4x plus 20. And then dividing both sides by 10 to isolate y, I've got y on the left equals negative 4 over 10. That's going to really reduce to negative 2/5 x. And then 20 over 10, that's going to give me a plus 2. All right, let me do this next one before I try graphing anything. So subtract the 20x and then divide by 50. I've got y equals negative, 20 over 50. That's really just negative 2/5 x. So that's interesting. That's going to be the same slope as we had over here. And then we've got 100 divided by 50, which is also 2. So graphing out this first one, which will actually be the second one as well, we have a y-intercept of 2 and a slope of negative 2/5. So that means down 2, right 5. So down 2, right 5. There we go. And draw the line through those. We didn't really need to draw the line, though, because if you have the same exact equation, then you have basically one line on top of another. So since those two lines, technically there's two lines going through here, since they're overlapping everywhere, we would say that we have infinite solutions, not just one particular solution.